Okay, so some of this will be review, theoretically. Some of it will be new. But we're going to talk about those three things: midpoints, distance, and Pythagorean theorem. Who didn't silence their phone? It's over there chirping. All right, we'll deal with that later. Okay. Hey, what's a midpoint?
Point in the middle.
A point in the middle. What's a loaf of bread? It's bread that comes in the form of a loaf. I'll try that again. Point in the middle of what?
A line.
A line.
Or a plane or something else.
Okay.
Oh, my first one was pretty simple.
A point in the middle of a segment. All right, Lucy, go up there. I won't hurt you. Go ahead. Grab one of the pens. See the little pen thing on the bottom? You got to click and pick a color there. Right there. Yeah, that one. There you go. Okay, good. Draw what you're describing, please. So let's start with a segment. Let's start with a segment, call it XY. Yeah, you can only put the pen on the screen, otherwise it tracks your hand. Okay. Or we'll use AB, that's okay. And let's call that, is that what you're calling the midpoint, that thing you're drawing now?
Yeah.
Okay, let's label it M. And thank you. You can sit down. Beautiful. Let's give it up for Lucy. So you said a point in the middle of what? A segment. Okay. Everybody agree? Yeah? Okay. Lucy? Is my M in the middle? Why not?
It's not equidistant from the A and B.
Say that again, louder.
It's not an equal distance from the A and B.
Oh, so now you're introducing another definition, right? How many automatically assumed that middle meant, what was the phrase you used?
Equal distance.
Equal distance from
A and B.
A and B, also known as the endpoints. So if you were just to say in the middle, is that detailed enough? Would everybody understand exactly what you were talking about? That's not a rhetorical question, answer me. Yes or no? No, there's some ambiguity as to what the middle is, which is why I followed it up more with Lucy, but then Lucy nailed it and said, what did you add to it?
The midpoint is equal distance from the endpoints.
Equal distance from the endpoints. Beautiful. So that eliminates my M and makes her M the thing that we would call a midpoint. How many points on that segment? If we get rid of the midpoints that Lucy and I were talking about, or just erase everything like a big dope. There we go. Let's put that segment AB down there. How many points on that segment, or make up that segment? Infinite. Good. How many midpoints? Just one. How many points between A and B? Infinite. Okay, so understand the difference? Because that's going to happen a lot in the problems that we look at. You're going to get a statement that says something like, put the point P between A and B. And we did this on Wednesday, right? So this would be okay. Is that P the midpoint? No, why, Brody?
Because it's not in like the very center.
Yeah, it's not equidistant from the endpoints. As opposed to saying, label M as the midpoint of the segment AB. Okay, remember we're talking segments here, we're not talking lines. We talked about lines the other day that go on forever. You can't find halfway between infinity. Well done, Lucy. Questions? So we're good. Okay, so the big difference is that if it's the midpoint, the two sides are equal. I think I have some pictures in my slideshow for you. Let me get this gunk out of the way. Okay, so there's, I use P, Q, and M. Notice the tick marks there. The tick marks say that PM, the segment PM, is equal to the segment NQ. What's the relationship, Evan, let's pick on you. What's the relationship between segment MQ and segment PQ?
It's like the relationship M or something.
No, let's talk lengths. What's the relationship between the length of MQ and the length of PQ?
MQ is half of.
Perfect. Okay, any problems? Now, if M is the midpoint, then like it says up here, we know that PM is equal to MQ. We know that MQ is half of PQ. We know that PM is half of MQ, or PQ, sorry. We know that PQ divided by 2 is equal to PM or MQ. So we have that relationship. If it's between, that equal relationship does not exist. Okay? Now, how do we find it? So we've been talking about, we just did 8 weeks of algebra. And when we were doing a lot of that algebra stuff, a lot of the points we were talking about were coordinate points. So what if we put that midpoint on a coordinate plane? We give it locations now. It's not just some point P and Q floating around in nowhere. We give them coordinates. If we want to find the midpoint then, we would take the average of the x coordinates and the average of the y coordinates. I'm pretty sure you've done this before, yes? Beautiful. So we're going to ramp this up a little bit. We're going to start with something simple. You might want your calculators. I don't know if you can add 2 numbers and divide by 2, but if you're struggling a little bit, bust out your calculators. Okay, we good? All right, let's try this guy. Now, I would highly recommend you draw a picture before you dive into this problem. You don't have to graph it. It's a waste of time. Just sketch a picture. And then calculate the location of M. Once you get an answer, check with the rest of your group to make sure you're all in agreement. If not, start fighting. Hold on, I'll show you the problem in a second. We're taking a formula time off. Okay, there we go.
All right. I don't know, have you asked them? I have no idea.
So I started applying my axes.
What's 2 minus 9? That's a 7. Oh, my bad. Okay. Jamie's got a different answer.
I did extreme
What do we got?
Stacy, my brain is gone.
What do those numbers represent?
I I know.
Plot a negative point. Can't you plot the point negative 2, negative 3?
It's just then what I would do is look at the coordinate plane. And I would say cosine.
How we doing, boys?
So that's what I would do.
How we doing?
So like if I got something like it. I'd be like, oh, that's wrong. So.
Because remember, you're finding the coordinates. Okay, so while we're watching Garrett, try not to put his hand all over the board. Remember what you're calculating here. I gave you the coordinate of an endpoint S. I gave you the coordinate of the endpoint T. You're looking for M. Well, what is M? M should be a coordinate, so you're going to get your answer in coordinate form. Parentheses separated by a comma. Can they be negative? Yes. Can they be positive? Yes. Can they be 0? Yes.
Bro, I swear this.
Beautiful. Got the work done. Okay? So, negative 14 plus 3 is negative 11 divided by 2. That's an average. By the way, I prefer you leave it in fraction form. I know he got all fancies and turned it into a decimal, but let's leave it in fraction form. Okay, questions? We're good? Everybody got the right answer? Yes? No problems? You sure? Because we're going to move on to something more interesting. No? Okay, here we go. Let's change the problem a little bit. What if, instead of giving you the 2 endpoints and you just plug and chug into that formula on the previous slide, I give you that scenario? Now, read the problem carefully. What am I doing? I gave you the midpoint, I gave you an endpoint, and now I'm asking you to find the other endpoint. Go. Highly recommend you draw a picture first. Good start. Picture looks good. You just took the average of those two exponents to find out the point of what you were finding in that if you find the midpoint of that kind. We don't want that. We want the points at that point. I don't know. I'm asking you. Keep going. And when you finish that, present that to the rest of them and see if they agree with you. You might either be a genius or completely psychotic, but we'll see what happens, see what they do. Are you wearing a mask so you're not tempted to talk? That reminds you not to talk.
No, it's to tell everyone else, because it's like,
I've got some blues. Just do a little spot over here where you put a straw on and you drink. Yes, sir.
I do multiply by 2.
I don't know. How do I know if that's right or not? So you're suggesting that's the midpoint, or that's the end point, right? Or that's your end point? Okay, well, let me use this. What if I did this? What if I did give you that? Now you're starting with that and that. You can check to see if that's, okay, good. What are we doing? Is that right? Do they agree with you? Those real immerse senses? That would sound after a while. Oh, that right.
Because a lot didn't qualify. So in that case, I'm assuming
We're gonna come back to that. Yes, sir.
they replaced it.
what'd you get?
The coordinate of that.
Just like it just basically that's what I thought. I was like trying to
Your picture is correct.
Okay.
Right, so M is at the coordinate 5 and -6. K is at 1, 2. So that should be 1, 2, that's 5. Move that 5, -6 over to M. I don't know.
What'd you do?
Bella got -2.
Okay.
I don't know. So, did it work?
I meant that. Okay. I'm using friendship, right? Geometry and algebra. Okay.
What you got, Ron? You got?
Yes. Great.
That's right. No?
I had
Why not?
Hold
on.
6, 7, and 8.
Talking to somebody.
I have some parents. Oh, breath. Because they have, yeah.
What do you want?
Is that one right?
So the way that I
Changes mind. But it's not honors. Oh, okay. It's not an honors.
You gave her that suggestion? Oh, you might not do so well in this class. Ever. All right, so let's attack this because there's at least 2 different ways to do this problem. Okay? So, let's suppose I had an idea. I did the work, and I came up with the location of L as being 2, 7. I'm pretty sure that's right. How I got it is not important. I'm really smart. How do I know if that's right?
Check it.
Talk a little bit about more than just
Well,
check it.
you take the coordinates of n and your supposed coordinates of L, and then you plug it into the formula from the last slide.
Okay. For those of you that struggle, this is what the picture looks like. So I'm suggesting that's 2, 7. We know that K is 1, 2, buckle my shoe. And if I plug it in, you're saying that I should get 5, -6. Do I? 2 plus 1 is 3 divided by 2 is 3. Has not correct. I am incorrect. Okay, so that didn't work. How do I solve this problem? So we all agree that if I get an answer, I can check it to see if it's correct by applying the midpoint formula to it. But obviously you can't do that for an infinite number of problems or points, so you have to have a process to get the location of L. Then if you're not sure about L, it's a little shaky, your group is arguing with you, you can check it using the midpoint formula. Okay, so question?
Well, since it's equidistant, couldn't you just take the distance between K and M and then add that to M? Or that'd be L?
You could. Do you know how to find the distance?
Well, you could just like 2 to -6, subtract 8, 1 to 5, add 4.
Interesting. I'll come back to you in a second. Okay, what did you do?
Wrong.
Did you erase it?
I did it wrong.
You bring all that back. You hit that little reverse button.
No, no.
I'm serious, do it.
But
Do-
I missed it.
Version in front of me.
I can't go back anymore. No, I mixed up
Bella.
the order of the letters.
You're up. So Bella got an answer of 9. Okay, I can use my own board. 9 -14. Okay, and she has no work on her paper. So I come by and I'm like, yo, Bella, you got no work. What makes you think that's the answer? And she said,
I just like thought about what like you could divide 5 to 8 to get 5 and -6. Like we could add.
keep going. Is that clear for everybody? No.
I don't know. Like because 9 plus 1 plus 10 divided by 2 plus 5.
So you guessed and checked the entire problem.
Yeah.
Okay. Interesting. What if the numbers get ugly? Would that still work?
Probably not.
Okay, let's go back to Scott. What were you talking about?
Um,
Just not a good way to start a sentence.
well,
There you go, that's better. Comma.
1 and 2, and it goes to 5 and 6, so it went up 4 in the X and then -8 in the Y. So you can apply the same to that one. But I did that and it ended up with 5 and -6 when I put the numbers there.
So you also got -14.
You know, if you add the 4 and then minus the 8, it's 9, -14, and then if you plug everything, it's 5 and -6.
Which is what we wanted. Good. Okay, so one method is to use this intuitive approach that Bella kind of hinted at and Scott clarified a little bit. The question is, what do I do to go from 1 to 5? Add 4. So therefore, add 4. I get to 9. Okay. What do I do to go from 2 to -6? Subtract 8. -6 minus 8. -14. Now all my math friends in the room are like, what? That's some sloppy math. And it is. So Rebecca, catch Rebecca. Horrible catch. Is going to put her erased work up on the board because she took an algebraic approach to it and solved it using some algebra, which is a little more mathematically sound. Come on.
Well, the first time I did it wrong.
Here, you want a blank screen? You want to do this? There you go.
It didn't work. Okay.
You want a different color?
No, it's fine.
All right, well, you're going to get blue anyways because it's Prospect. Okay, stop a second. First of all, could you get that extra line out of there? It's freaking me out. Thank you. So happy. You're going to need to explain that. Do you
Oh.
understand what she's doing? Yeah. See it? Do you understand what she's doing? Okay, good. Bella, do you understand what she's doing? You do. Oh, good. That makes one of us. Abby, you good? No. Okay, so we want an explanation, right? Okay, you're my new best friend. All right. I don't understand.
Well, this is the formula to get that.
What's that?
That's the x coordinate for the point we're trying to find.
Oh.
And then So for
Hold
this,
on 1 second.
mhm.
Oh, we need more clarification.
So we have the midpoint and one endpoint. So this is the endpoint that we have, which the x-coordinate is 1.
Uh-huh.
And then for the endpoint that we're trying to find, we don't have the x-coordinate, so we just put an x. And then that is the midpoint. That's the x-coordinate of the midpoint,
Mm-hmm.
because like you do that to find the midpoint.
Hold on 1 second. Okay. Yeah, we're good. Hello, person at the door.
Hi. Hello, honored Jew. I was listening to the explanation. It's fabulous.
Okay, good. Oh, look, that's the same answer we got.
Wow.
Wow. Sarcasm, one of your stronger points. Nicely done.
What did I do?
My board. That's what happens when you let the kids drive the car. There you go. Hey, let's give it up, huh? Which method is more corrector? Neither. You can use whichever one you want. However, what I don't want to see is just answers appear out of nowhere. So if you use Bella and Scott's technique, that's fine. But what you should do is incorporate some type of graphic to show me that's where the answer comes from. You remember I drew my picture quickly. I had K, I had M, I had L, and I made a bunch of curvy things there, and you go, I don't know that. That would be considered work. If you use Rebecca's method, then you're setting up some algebraic equations and solving that. I don't care which one you use. You can show your work for both. You can get the correct answer from both. Okay. Questions? Be sure you read the problems carefully. Sometimes I will ask you for the midpoint, sometimes I'll ask you for the other endpoint. Are we good? All right, beautiful. Okay,
Sorry,
let's
our
do
middle
some.
school
Are you
teachers.
taking them?
We're gonna go back downstairs.
All right, bye,
But
everybody.
thank you, Mr.
Thanks for
Reader.
coming. If you have any questions, email you. Ms. Evans, can you give them my
I'll give them
email?
your
if they have
contact
questions?
info.
Twin sister. That's why she's not waving at me.
I did the same thing. I thought she was sitting in a different math class. I'm like, why are you here? And her sister looked at me like,
I'm her
"Who are you?"
sister. I know, it's hard.
Go. All right. Now stranger danger is over. All right, solve this one. Again, start with a picture, just like we did on Wednesday. Label your distances, set up an equation, and solve. How many of you recognize an old teacher? Interesting. Okay. Was that a good thing or a bad thing? They're gone. Good thing. Okay. Brody, you didn't answer.
I originally did.
No, I know. Good thing or bad thing?
Good thing.
Okay.
Yeah.
That's a safe answer.
Kind of felt pressure's not worked out, but
You know, you come into class and you think, I'm going to have a great Friday. Rosemary can't talk. And I'm thinking, yeah, it's tough. I got some math teachers in here observing.
What?
But it'll be okay because Rosemary can't talk. And then all of a sudden Rosemary finds the speech function on her iPad, and Friday goes right in the crapper. Go. Come on. Some of you that are struggling, you're probably thinking to yourself, he didn't give me enough information. Think about the problem. This is different than what we did on Wednesday because of one important word, and that word is math. Good. Math.
Someone's phone's going crazy.
Yeah. What's special about the phone?
You're a smart one,
Go. She pointed out a great point. Okay. She pointedly pointed out a great point. That was question 5.
Brody, I can't lie. I'm kind of missing out.
3 plus 6x minus 3 equals 14x plus 2 is the same thing as 14x plus 3 minus 8 minus 8.
Come back Wednesday.
It's 1 plus 1 equals 2 is the same thing as minus 1.
What? Do you know Cameron Christopher?
He's a redhead. Oh, sorry. Is he good?
I think he's the assistant, so it's
No, because we need to do variables. Oh, look at me in that photo.
Yeah, did
you draw a picture? Okay, so does this match your picture? Correct. So that's the gist of, don't erase it. Because you can adapt that to something. But ask yourself, what's the relation?
I just didn't know why that's saying.
You want to be able to solve it, not just get it.
Just use your voice.
Okay.
Yes, she can.
Let's talk about some of the ideas that are associated with this problem. First of all, drawing a picture. What are the labels on the endpoints of this bad boy? P and R. Okay, good. And O is the midpoint. If O is the, whoops, not Q, Reedy. If O is the midpoint, before I put any algebraic expressions in there, what's true about that picture? Listen.
PO or PR is like 14x plus 2 is the whole segment.
Uh-huh.
And then OR is half of that.
Uh-huh.
And then
Wait, say that again.
OR is half the segment.
Bingo. OR is half of PR. Or PR is twice as big as OR. Why is that true? Because of this pesky little phrase. Okay? From the picture, we have this. So now if we label things, this is 14x plus 2. This is 6 minus 3x. Lucy, how long is PO, algebraically speaking?
6 minus 3x.
Beautiful. So let me stop because that's an important idea. Because O is the midpoint, as Lucy said, PO, well, Lucy didn't say this. Lucy said, we'll come back to what Lucy said. I'm saying now that PO has to also be 6 minus 3x. Everybody good? So I'm going to come back to you in a second, Lucy, because you have a different way to solve the problem than the way I'm about to solve it. Based on that picture then, what equation would you set up?
6 minus 3x plus 6 minus 3x equals 14x minus 2, or plus 2.
Bingo. 6 minus 3x plus 6 minus 3x is equal to 14x plus 2. The two smaller sticks added together give me the big stick. Beautiful. Okay, now, let's talk about the way Lucy phrased it. Lucy, you said that PO is half of PR?
Yes.
Okay, so let's write that down. PO is half of PR, which means that 6 minus 3x is equal to 1/2 times the quantity, 14x plus 2. Those equations are very similar, but they're not the same. If you are feeling fancies in your pantsies, you've got a third option here, which is 2 times the quantity, 6 minus 3x, equals 14x plus 2. All of those represent the same thing. The two little segments are half as long as the big segment. One of the little segments doubled, gives you the big segment. And I'm going to assume that you're able to solve that linear equation, because we just did that 8 stinking weeks. Okay. Now,
Equation doesn't work because negative 3 subtracted by 3x would be negative 6x, and 6 plus 6 would be 12, and that does not equal 14.
what? Solve that. Move the x's to one side and solve it. Look at that. Again, not everything's a pretty answer. What did you get? 5/4 for x? Yes?
No.
No?
No, I got
Uh-oh.
half.
Oh, I subtracted.
Come on. All right, so x is 1/2. The last thing I'll say about this problem is you should all be able to solve the linear equation theoretically, and then make sure you answer the question. Notice the question doesn't say how big is x. It says how long is PO. So you have to plug back in to get your answer. Okay. What is not an acceptable answer in this problem is an algebraic expression. Don't tell me that PO is 6 minus 3x. You're working towards a numerical value. Okay, we good? Question, Andy? 6 minus 3x. Well, actually, I'm going to answer your question with a variety of answers. You can plug it in wherever you want. You know, you could, for instance. So Abby just asked a good question. She said, where do I plug the 1/2 in? My answer was originally 6 minus 3x, but you can plug it in anywhere. I could plug it in up here and find out that this is 1/2 times 14 is 7 plus 2 is, 7 plus 2 is 9, right? So that means the whole segment is 9. So therefore, how long is PO? It's half of 9, 4.5. We good? Awesome. Yeah, there's the word. Okay, cool. If O is not the midpoint and it's just between, then we're looking at problems like we did on Wednesday, which we'll come back to later. Okay, then we need a different relationship. Good? David?
Would PO plus OR equal PR?
Always. Whether it's a midpoint or between, those two segments are going to add up to be the big segment. The two little guys add up to be the big side. If it's midpoint, then the two sides are equal. They still add up to be the big one. If it's between, then the two little parts add up to get to be the big one. Question? Certainly. Well, we're going to take a break in a second. Hold on. Okay. So, last definition, and then we'll take a break before we dive into the last two things to finish up. Okay, what is a bisector? Let's break the word apart. What does bi mean? Two. What does sect mean?
Cut.
To cut. Correct. So a bisector cuts something in half. For our purposes, a bisector is a line, a segment, or a plane that bisects, I'm using the word to define it, that's horrible, that cuts a segment in half. There are some pictures for you. A midpoint is a bisector. That orange line in the middle is a bisector. That plane, that white plane in the right picture, is a bisector. Okay, it's passing through the midpoint. It's bisecting the segment, cutting it into two equal parts. Okay, let me check something real quick.
Wait, can you go back?
Yeah, I'm not going anywhere. It's okay. Sorry. Sorry. We're good.
Oh, that's points. Mr. Reedy, I think this was on our homework, but we didn't know what it was.
That would be Penelope's fault then.
No.
No.
It made sense on the homework.
Oh, good. All right, let's take a 2-minute break now. We'll go again at 9:20. So if you need to get a drink of water, go to the bathroom, get up, stretch your legs. Go do that, and then at 9:20 we'll pick up where we left off.
It's like you get to go somewhere to like play music and stuff, and it's like only like the best of the best in the whole.
20?
I'm so happy for you, and Emily, and you're my mom. Duncan Collins? No. Super good, but he's a junior. Everybody else is.
No, why are you on the screen downstairs?
He's like really good. And definitely the best.
You know, I hacked it and put you on there.
It's his name. Duncan Waddle. His brother's name is yeah, it's we're down, but I
Nintendo results,
Oh, yeah! He's like coming from
So I gave it to you.
Excuse me? For this one where PO plus OR equals PR,
Yep.
I filled it in and I got some different answer.
Well, that's because you need a number to set it equal to. In other words, you need to get a numerical value there, so you need to solve for x.
So what do you mean?
So you have to solve for x.
That's not allowing us to solve for the variable x to find a numerical value. You have an algebraic expression for PO. This is not a false statement. It doesn't tell me the number, though. How long is that segment? We want to know how long that segment is. So you need to set up a different equation which allows you to solve for x and then plug it back in. All right, let's pick up where we left off. One of them might not make any sense. They both might make sense. One of them might make sense.
They both make sense.
All right, so we've got some interesting things to do. We're going to skip this because after looking at your midterms, Most of you are very good at simplifying radicals, so we're not going to spend the time doing that. We're going to move on to something called Pythagorean Theorem. Now notice it says review of Pythagorean Theorem because you've done it already. You better have last year, yes?
Yeah.
Olivia, what's Pythagorean Theorem?
I remember.
What you would have got?
A squared plus B squared equals C squared.
Kind of. That's the Pythagorean Theorem. In a right triangle, the sum of the squares of the measures of the length equals the square of the measure of the hypotenuse.
Same thing.
Same thing. Yes, it is a squared plus b squared equals c squared. Now, there's some words in there that we haven't talked about. We haven't talked about what a right triangle is. We'll get to that later, but I think since you've done Pythagorean Theorem, you already know what a right triangle is. What is a hypotenuse? Go ahead.
So where the right triangle and then it's like the part that's like slanted.
Okay, so if I give you a triangle,
Is it C?
and I say, go find the hypotenuse, or point to the hypotenuse would be a better question. How would you do that, Meg? Beautiful. Two ways. Number one, it's the longest side. Number two, it's across from the right angle. Now here's the problem. If you just memorize a squared plus b squared equals c squared, and I label my triangle differently, that's going to cause a problem. So you don't need to memorize that paragraph at the top, but you do need to understand you take the two shorter sides, you square each of them, you add it up, and that equals the third side squared. Which is what that thing says in the paragraph. Even though I've said that, you're all just going to do a squared plus b squared equals c squared. And again, this is a review, so let's see how you did. Solve that, please. I would start with a picture, as always. And you might want your calculators. Cold coffee. Question or answer? Hold.
Mr. Reed, did I get which one is it?
Does that mean you would fight me? Or does that mean I got it right? Or I'm choking and I can't breathe? But did you get the right answer? I could say the answer is paperclip, but that doesn't mean it's the right answer.
So like, for example,
Then you square all.
Like, no.
Well, I mean, if you fail,
Oh, there's the strategy. No, she just couldn't cut it. She had to go. All right, 13, yes?
Yeah.
All right, good. If your answers turn out to be pretty, meaning they are whole number answers, okay, so 5, 12, 13, that's what's called a Pythagorean triple. The cool thing about a Pythagorean triple then is any other combination of those three numbers will also work. So for instance, we just solved the 5, 12, 13 triangle, it's called. If you double all those numbers, a 10, 24, 26 triangle will also work. That's
it's called the what now again?
Pythagorean triple. Now, be careful. When I give you a Pythagorean theorem problem, draw the picture, because what many of you are going to do is automatically assume that take the two numbers I give you, square them, add them, and solve for the new third side. You're going to assume I'm asking you to find c in the a squared plus b squared equals c squared. That won't be the case. For instance, in this triangle, solve that, please. Again, you might want to draw a triangle.
It doesn't matter, so we can air.
What did you get? Oh, either. She's typing. I'm running away.
We do not like repeating decimals.
Oh, Abby, great question. So Abby just asked the question, what if it's not a whole number? So hopefully you found that that short side is the square root of 429, yes?
Yeah.
Okay, so let's talk about that answer. I'm not going to talk about how you got that answer because I'm assuming you were all able to get this. I'm going to ask you for two different types of solutions. I'm going to ask you for an exact answer, and I'm going to ask you for an approximate answer. So the exact answer would be leaving it in radical form. Okay. However, it should be simplified. 429 is an ugly number. We'll just pretend that that's simplified for discussion purposes. Okay, this is exact. Involves a radical. Okay. However, I will also ask you for an approximate answer. The approximate answer will be the number that you get when you type in the square root of 429, which is about what, Emma? Thank you, Emma. 20.7. Our standard here is we're going to round to one decimal place. Okay? Now notice I said round, not truncate. What number comes after the 7? So therefore 20.7 is the correct answer. Is it safe to assume you all know how to round? Okay, we'll see. Problems? Okay, good. On the Pythagorean question?
Don't you like it to be a fraction?
That can't go into a fraction.
7 tenths.
Because that's an approximation.
Oh, yeah.
On the Pythagorean theorem problems, be careful and make sure that you are applying the equation correctly. Are you looking for the third long side, also known as the hypotenuse, so your variable goes into C? Or are you looking for one of the legs, so your variable is either A or B? Are we good? You've done this before, yes? Awesome. Let's talk about the distance formula. You've done distance formula before, yes? Okay, well, I'm sure you haven't done what I'm about to show you. Okay, so, put your pens down and just be mathematical sponges and absorb information. Okay? What I'm about to show you is the origin of the distance formula. You don't need to memorize where this comes from, but I think it helps understanding the distance formula. Some of you are just going to take the final distance formula, go home and memorize the snot out of it. That's fine. But again, I think it's helpful to see where the formula comes from. Okay, so here's my scenario. I've got a coordinate plane, and I put two random points on the plane. Now, you're saying to yourself, oh, well, we know exactly where those are. No, you don't. They're just random points. I called one x1, y1. I called the other one x2, y2. So based on what we did at the beginning of the class, you could tell me what the midpoint of that segment is. That segment there, by the way. But I don't care about that. I want to know the length of that segment on the coordinate plane. And in the back of your brain, you're thinking, oh yeah, we used to have a formula. Some of you might even be able to puke up that formula right now, but I don't care. I'm going to show you where the formula comes from. Okay, so here's the key to this problem. I'm going to draw a vertical line from one point down. A vertical segment from x1, y1 down to the horizontal value of x2, y2. So here's the question. How long is that red segment? Now, don't count squares. Don't tell me it's 2, 4, 6, 7 units. Because we're just taking random points that could be anywhere on the plane. Amy?
y2 minus y1.
Close.
Y1 minus Y2.
y1 minus y2. Outstanding. Everybody good with that? That's the difference in the y-coordinates. It's a vertical line. Or vertical line segment, I should say. So therefore, its length is the top coordinate minus the bottom coordinate. Are we good? Questions? Okay. How long, Damien, how long is the blue segment?
The blue segment is x1 minus x2.
Couldn't have said it better myself.
We did this.
No.
Yeah, in 7th grade.
Your middle school teacher showed you the origin of the distance formula.
Mrs. Marston.
Hot diggity.
I don't know what she
Mrs. Marston should win a prize. Should have given her a sticker. Like a Thanos sticker. Or a mushroom.
Mushroom.
I got mushroom stickers.
Yeah,
Okay, anyways. Now, what kind of triangle are you looking at? A right triangle. What applies to right triangles? Pythagorean Theorem. If I apply the Pythagorean Theorem to this mess, I take the red leg and square it, I add it to the blue leg and square it, and I'll get the distance squared. But I don't want the distance squared, I want the distance. So I'm going to take the square root of both sides, and you get the distance formula. This is what you should write down now. And that formula should look familiar.
We definitely did this.
I'm going to close the door for my next little rant, which is kind of ironic because I'm recording the lesson anyways. Okay, so
Good thing for us.
what we're going to do in the future is, thank you, I guess I wasn't strong enough. What we're going to do in the future is we're going to practice this distance formula. So there are others that would believe that you should do the distance formula over and over by hand. I hate that idea. So eventually being next week, we're going to do some programming on your calculators. And you're going to learn how to program your calculator. And the goal of that, one of the goals of that programming, is to program the distance formula into your calculator, to have the calculator do the work for you. Okay, that's going to take a little bit of time, but we'll get there eventually. Initially now, you're just going to have to practice. When you're doing the distance formula, make sure you get the signs correct. x1 minus x2, quantity squared, plus y1 minus y2 quantity squared, and then take the square root of that whole thing. Okay, everybody got the formula? We're good? Let's practice. Exact distance. What I mean by that is when you're done, if you have a square root, leave it in square root form. Go ahead. Certainly.
Why is it x1 minus x2 and not x2 minus x1?
Ooh, great question. So Bob just asked a great question. Why is it x1 minus x2 and not x2 minus x1? In this case, it doesn't matter. Because you're squaring it, if you do it the other way around, you'll get the same answer. So in other words, okay, so do this. Damien, you're going to consider point A, x1, y1. Okay. you're going to do point B, bow. You're going to do B as x1, y1. Calculate the distance, compare your answers. I'm going to talk while you're working. We're not going to get to the homework from Wednesday. So the first thing we'll do on next Wednesday when I see you again is we'll get caught up on the day 1 and the day 2 homework before we move on to day 2. I've updated the calendar so when you get on to Schoology you will notice the dates for the first quiz are on there. It will be next Friday. Question here in the front. Uh-oh. Okay, glad I get out. Okay, stop what you're doing for a second. This is important. On your calculators, please type -7 squared. Do this. Tell me what you get for an answer.
-49.
What did you do wrong?
You didn't put that.
Good. So, when you're solving these problems, there's a big difference between this versus this. In the left picture, the left expression, what's being squared? The 2. And then there's a minus sign sitting out in front. So what this does is it takes the 2 and squares it, and you get -4. What is this doing? It's squaring the whole thing. -2 times -2 is 4. Which one do we want? Second one. Now, let's be honest. You should all be able to do -7 times -7 and realize it's a positive answer, and 7 times 7 is 49. But when the problems get nastier or you happen to be on the struggle bus, make sure you understand the difference between those two things. Okay, answers. Bella. It's not a good way to start a sentence. Start over. Well, tell me what you got without simplifying. Square root of 50. Yes?
Do you leave it as that or do you simplify it?
I was just going to get to that. Do we leave it as that or do we simplify it?
Leave it because it says find the exact answer.
No, you simplify it.
Or-
Now, by simplifying, I don't mean put it into your calculator and tell me that it's about 7 point blah, blah, blah. What I mean is you simplify your radical. Square root of 50. Square root of 25 times the square root of 2. 5 square roots of 2. This is what I want. You won't do that a lot. I don't really care about exact different distances that much, but some problems it will be advantageous to leave it in exact form. We'll get to those later. Realistically, what I would have you do is take the square root of 50, type it into your calculator, and get about 7.1. Good. Brooke.
I got -48.
Ooh. That's good. I mean, it's not good. It's wrong, but let me show you why you got that. All right. I'm going to answer your question by dealing with these two schlubs over here. Did you both get the same answer? Okay. So did you do this as x1, y1, or this as x1, y1? Distance equals the square root of what minus what?
It's x1 minus x2.
Right. So what did you plug in?
I put 3 minus 4. -3 minus 4.
-3 minus 4 quantity squared plus -5 minus -6 quantity squared. We're on the same page. Okay. -3 minus 4 is -7 quantity squared plus 1 squared. Square root of the whole thing equals. This is what I was talking about.
Yeah.
What's -7 squared? Negative times a negative, positive. Okay. Good. Hot diggity. Get this out of the way. Oh, we're running out of time. I can't believe we've been doing it this long. Okay, erasing. All right, last one.
Do we have homework?
Of course you have homework. Find the approximate distance between those 2 points. This time, when you get your square root answer, you're going to type it in and tell me the decimal equivalent. Again, I'm going to talk while you're working. One thing that Damien and Bob figured out over here is it doesn't matter which point you consider x1, y1, or which point you consider x2, y2, as long as you keep it consistent. If you do g first, then you got to do g first for both of them. If you do b first, you got to do b first for both of them.
Do you want the exact decimals or rounded?
Approximate distance, por favor. That's Spanish for please. Your turn. I'll bring that up there with you because I'll give you a whole. I'll do this for you.
Del or do? Why can't we just write with our fingers so that our hand doesn't get caught?
You can if you'd like. What color do you want?
Blue.
There you go. Because we're prospect.
Yeah.
Hoorah!
Oh. Bad start.
You could write with all 10 of your fingers if you want. It'll read 20 different points at the same time. So you could put all 10 of your fingers up there, all 10 of his fingers, and it would still be.
My old neighbor used to have 11 fingers.
So he was a, what do they call it? Holly Jack. There's a term for that. Yeah.
She was born with like an actual pinky.
So when she was drinking tea, she'd have 2 pinkies up in the air.
She was
If she ever met the queen, she'd be like double pinking the queen.
She got removed.
How do they do that? They just do that off the drive with a pair of rusty pants.
They use this jigsaw.
Yeah, nice. Then she turned it into a necklace and wore it around to school.
Yeah, like it was.
When you say it's wrong, you say why, but she got the wrong. What?
We'll do this part later. This is squared, so it doesn't matter which one. The slope lines together, plug in the one that was big.
Awesome. All right.
Well, what's it?
I'll take that.
So it's
So Evan does the work. He gets a square root of 94. Now, if you want to be all nerdy and push your glasses up, you could do this. Yeah. You know what that stands for? Approximately equal to. Not required. It's just if you want to get fancies in your fancies. Okay. Well done. Let's give it up for Evan. Also notice, perfect job of showing work. I can see exactly where he plugged each of those numbers into the equation. I can see how he simplified the equation, and I can see where his final answer comes from. I can't grade things that aren't there. You understand what I mean by that? So if he gets the incorrect answer and there's no work, he's going to lose all the points. If he shows his work like this, like let's say for instance he takes a 1 minus 6 and gets 7, then I know where he made a mistake and I'm not going to take off all the points, I'm going to take one of those points. Good. We're all done. Okay. Now, I apologize for the length of the lesson. There was a lot of stuff we needed to cover and I didn't go as fast as I normally would because I wanted to slow things down and see how a slower pace worked with all of you. Even though most of this is supposed to be review, maybe that midpoint problem that we did is not review, but it gives you an idea of what you need to have ready to go. Okay, so Wednesday, again in a week, or whatever, next week I should say, we'll go over the day 1 homework. I want to take a look at some of those algebra problems that you did. In particular, there was a quadratic problem on one of the homework problems. And then we'll take a look at the day 2 homework, and then we'll do a little bit more practice. I'm pretty sure, I could be wrong, but I'm pretty sure we will not have a new lesson on Wednesday. Could be wrong on that, I'll let you know. Okay? Questions?
When are we getting our midterms back?
On Wednesday, I will take an opportunity for you to come up and you don't get to keep your midterms. You can come up with me and look at them if you want to see what you did right and wrong. I will have them done by probably tomorrow, so that your grades will go up online. And then they'll be done for the quarter grades for Tuesday. Enjoy your day off Monday. I don't know why I'm still recording this. Hold on.